So now that we've looked at what to do when we have a number outside or in front of brackets, we're going to incorporate that understanding or that knowledge with being able to solve equations with brackets. So we're going to take that idea of distributing property to help us get rid of the brackets and then use our understanding of either multi-step equations or one and two-step equations to help us solve. So in example 1 or example A, I want to get rid of these brackets. So in order to do that, I need to take the 2 that's in front of the brackets and multiply it by everything inside the bracket. Right? It's not going to multiply the 10 because the 10 is not part of that bracket. So again, remember distributive property, you're only multiplying by things inside the bracket. So 2 times x, we get 2x, and then 2 times positive 3 is positive 6 equals 10. So now I've gotten rid of my brackets, I can now work at solving my equation. Again, remember, when I'm solving equations, I want to make sure all my variable terms are grouped together. In this case, I only have 1, which is good, and it's all together. Then what I'm going to do, I need to start with reverse BEDMAS, so looking for subtraction or addition first to take care of it and cancel it out. So I can see I have plus 6, so I want to cancel it out by subtracting 6, and I'm going to do the same to the other side, and they're going to cancel out. It's going to cancel out on the one side, right? Because if I add 6 and subtract 6, it makes 0. And then I'm left with 2x equals 10 minus 6, which is 4. The next step, I want to get rid of this 2 to get x by itself. Again, remember the goal of solving an equation is to isolate or get a variable by itself. So in order to cancel out the 2, I have to look at what operation is going on. Remember, when we see a coefficient or a number and a letter, we assume that it's multiplying, or multiplying is the operation if we don't see anything or any sign. I don't see any sign, so it's multiplying, and in order to cancel out multiplying, I do the opposite, or divide. And I have to divide the other side by 2 as well to keep things balanced. One side cancels out, and I'm left with x equals 2. So that is my final answer. Moving over to B, again, same idea. I have an equation that I want to solve, but I have brackets. So in order to deal with this, I need to get rid of the brackets by multiplying everything inside by the number that's out front, or the multiplier. So in this case, everything inside the bracket is getting multiplied by 4. So 4x, and then minus 12, so 4 times negative 3 is the negative 12, equals 2x, which I'm going to leave. Now, I have a multi-step equation. Because I have variable terms, or more than one variable term. And in this case, my variable terms are on different sides of the equal sign, so I need to move them to get them over to one side. I'm going to move the 4x over, or get rid of the 4x on this side, because I'm trying to get everything away, or x on its own, and if I move everything over to the left side, then it just adds more work because then I have to move the 12 over to the other side. So I'm going to get rid of the 4x by subtracting 4x. I'm going to do the same thing to the other side. One side just cancels out, and I'm left with negative 12 equals negative 2x. Now my x's are on one side only, so now I can work at isolating them. There's only one operation, which is multiplying, so I'm going to cancel that out by dividing. So I'm going to divide by negative 2. I'm going to do the same thing to the other side to balance it. One side cancels out, and I'm left with x on the one side and 6 on the other. So again, even though this is a little bit reversed, it's still fine and it still works out and we still get our answer. X is equal to 6. In example C, again, I have my brackets, which I want to get rid of, and then I want to start solving my equation. So to get rid of the brackets, the 5 has to be multiplied to everything on the inside. 5 times x is 5x. 5 times negative 1 is negative 5. And then everything on the right side just stays the way it is because there's no brackets and there's nothing I can do to simplify. Here, again, we have multiple variable terms, so I have x's on both sides of the equal sign, and I want to get them only to one side, or I only want them on one side. So I'm going to work at canceling one side out. I'm going to pick getting rid of the 2x. So I'm going to subtract 2x. I'm going to do the same thing to the other side to balance it out. It'll cancel out on one side, and I'm left with 3x minus 5 equals negative 8. Now I want to work at getting x by itself. So there is some subtraction that's associated with the x. Right? Again, you want to look for subtraction or addition first. So in this case, I see the subtraction, I want to get rid of that. In order to cancel it out, I have to do the opposite, or addition. So I'm going to add 5. I'm going to add 5 to the other side to keep things balanced. One side will cancel out, and we're left with 3x equals negative 3. Now I need to get the x by itself again still, so I'm going to divide by 3, do it to the other side to balance it out. One side cancels out, and I'm left with x equals negative 1. If you were comfortable with this, what you could do is after you use the distributive property to get rid of the brackets, you could just jump down right to this last step if you're comfortable doing two movements at once. So if you're comfortable moving the 2 or subtracting 2x and adding 5, right? So doing these two movements, right? Getting rid of the 2x on the one side, getting rid of the 5 or the negative 5 on the other. You could go from here down to here, but again, try to show as much work as possible, especially if you're unsure, and then that way if you get something wrong, you still have enough work to show part marks, or to get part marks, or to at least show some of your understanding. Example D. So again, this one looks a little bit more confusing. There's more to it, but we're going to stick with the same thing that we've been doing. We're going to get rid of the brackets by multiplying the number outside by everything inside the bracket. So the 7 is going to multiply by the x and negative 1. The 6 I'm going to leave alone. It's just added. There's nothing multiplying to it. And then on the other side of the equal sign, the 2 times x and 2 times negative 3, or getting rid of this set of brackets. So 7x, and then 7 times negative 1 is negative 7, plus 6 I'm going to leave. And then on the other side, 2x and negative 6. So what I'm going to do now is I'm going to collect some like terms. Right? I'm going to simplify as much as I can on either side before starting to move things. So 7x and then negative 7 plus 6 is negative 1. Will equal 2x minus 6. Again, I want to get my variable terms on the same side. So I'm going to subtract 2x from the one side, subtract 2x from the other side. One side cancels out. I'm left with 5x minus 1 equals negative 6. I want to get rid of the negative 1 first, so I'm going to add 1 to the other side to cancel out. I'm left with 5x equals negative 5. And then lastly, I'm going to divide by 5. Oops, not negative 5. I'm going to divide by 5. Divide the other side by 5. One side cancels out. I'm left with x equals negative 1. And that is my solution. So again, solving equations with brackets is taking that understanding of the distributive property and just applying it to solving equations. Right? We use the distributive property to expand or drop those brackets, and then we move into either a multi-step equation, a two-step equation, or a one-step equation. And so we're just going through those same steps of isolating for that variable.